All right, we are in grade 10 mathematics, and then we are doing some revisions. One, here we are going to be looking at sets. Now we will have a few questions. Let me call this A. So set A is the set of factors of 30. Then set B is the set of factors of 24. And set C is the set of factors of 36. All right. So the question is list okay, let me just remove this. Let me just remove this here. Let me remove this here. Yeah, let me just remove this here so that we have a 1a here. List the elements in the following sets. List the elements in the following sets. So list the elements in the following set. A. Okay. How do you do that? How do you list the elements in set A? If set A is the set of factors of 30, how do you list those elements? All right. This is what you do. You will say set A. The elements of set A are factors of 30. 1, 2, 3, 5, 6. All right. 6, 10, 15, and 30. Yeah. 1 times 30 is 30. 2 times 15 is 30. 3 times 10 is 30. 5 times 6 is 30. So all these are the factors of 30. All right. Okay. Now, Roman figure 2. Roman figure 2. The elements of set B. Okay. The elements of set B. So you will say set B, the set of factors of 24. 1, 2, 3, 4, 6, 8, 12, okay, 24. 1 times 24 is 24. So 1 and 24 are the factors of 24. 2 times 12 is 24. 3 times 8 is 24. 4 times 6 is 24. So all these elements are factors of 24. Okay? Now, Roman figure 3. The elements of set C. So what do? You say, okay, set C is the set of factors of 36. 1, 2, 3, 6, 3, 4, yeah, 4, 6, 9, Am I right? 12, um, 12, 12 and what? 18, then 36. 1 times 36 is 36. 2 times 18 is 36. 3 times 12 is 36. 4 times 9 is 36. And then 6 times 6 is 36. So these are the elements, factors of 36. Okay? Now, let's continue. Let's continue. Now, we are here now. We want to look at Roman figure 4. And Roman figure 4 is A intersect B. List the elements of A intersect B. What do we do? You will say A intersect B, the elements. So intersection, that's a symbol, set symbol, which means common elements. So A intersect B means uh, elements common in set A and set B. Elements which are found in both set A and set B. Let's look at set A. Set A is this one, set B is this one. So you see that there is one here, two in this set, two in this set, three in this set, three in this set. There is no five in this set. There is no four in that set. Six is common in both sets. 10 no, 8 no, 15 no, 12 no, 30 no, 24 no. Now, those elements are 1, 2, okay, 3, 6. These are the elements common in set A and set B. Okay. All right. Let's see. We have Roman figure 5, which is about B intersect C. B intersect C. So what do we do? B intersect C. If you list those elements, what you have to understand is you are talking about elements both found in both set B and set C. So let's look at set B. Set B is this one. Now, C is this one. So you have 1 and 1, 2 and 2, 3 and 3, 4 and 4, 6 and 6, 12 and 12 here. Okay? So B intersect C would be 1, 2, 3, 4, 6, 12. Okay? These are the elements in set B intersect set C. All right. This is basically what you can do. Now part B of this question says we write it down. You write it down. Let me just say B. You write down the sets of common factors of 30, 24, and 36. Common factors of 30, 24, and 36. Now, that means we are going to look at the three sets. Set A, set B, set C. Factors of 30, factors of 24, factors of 36. What we want to do is to find the common factors. Okay? Elements that appear in the three sets. So we have 1, okay? Okay? We have 2. Do we have 3? Yes, even 3. What about 4? No. What about 6? Yes, 6. Any other element? 10 no, 15 no, 30 no. So even 12 no. So these are the elements. Common factors. Common factors would be 1, 2, 3, 6. These are the common factors between 24, 30, and 36. All right, now part C, part C of this question um, um, says, what is the highest common factor of 30, 24, and 36? What is the highest common factor? So the common factors are this. This is the lowest common factor, but 6 is the highest common factor. Highest common factor is 6. Okay? It's the highest common factor. But this is the set of common factors. Okay? Yeah. Now, this is actually um, uh, a question that is, I found it to be very interesting. I found it to be very interesting because it deals with factors, common factors. It also deals with sets. All right. Now, listing elements in a set. Now, let's go to part two of our revision. Part two of our revision. And in part two of our revision, we are looking at um, basic operations. Basic operations. Part two, basic operations. Um, This is whereby you will be adding, subtracting, multiplying, and dividing fractions, decimals, whole numbers, and so on. So basic operations are just addition, subtraction, multiplication, and division of types of numbers, different types of numbers. This is the most common topic because it appears in almost every topic in mathematics. Now let's look what we can do. The question may say work out 5 over 16 plus 2 1 over 8. All right, you may have this type of equation. Work out. What do you do? Then you need to study the types of numbers that you are dealing with. These are mixed numbers, and the operation is addition. You are adding mixed numbers. So what we usually advise you to do is to actually change this into an improper fraction. So you are going to say uh, 16 times 5, then plus 5. Even here you are going to say 8 times 2, then plus 1. Okay? That's basically what we do here. So we are going to have 16 times 5, which is 80. Okay? Then plus 5, which is 85. So this is going to be equal to 85 over the denominator here, which is 16, plus 8 times 2 is 16, plus 1 is 17 over the denominator here, which is 8. All right. Now, what do we do? The next thing is to realize that we are adding fractions with different denominators. Then we need to find the lowest common multiple of these two numbers, 16 and 8. Then we will discover that it is 16. So we put it below our line here, and we are going to say 16 into this 16 goes one time. Then 1 times 85 is 85. Then plus 8 into this 16 goes 2 times. 2 times 17 is 34. Now we have this fraction. The numerator has 2 times. Let's simplify it. We are going to say 85 plus 34, when we get 119. then over 16. Then we can simplify this. We can simplify this. So 16 into this 119, 16 into 119 goes 7 times. What does it leave? 16 into that goes 7 times. So what does it leave? It leaves 7. It leaves 7 over 16. So this would be an answer. Okay? Yeah. Now let's continue and see what we can do. Let's go to example 2. We say 3.5 minus 1 over 3. This is a mixed number, this is a fraction. So let's work out this. Work out this. What we need to do here is just to change this into an improper fraction. 2 times 3 is 6 plus 1 is 7. 7 over 2 minus 1 over 3. Now, the next thing is to understand that we are subtracting fractions, so we follow the same approach. We will find the lowest common multiple of 2 and 3, and that is 6. Then 2 into 6 goes 3 times. 3 times 7 is 21, minus 3 into 6 goes 2 times. 2 times 1 is 2. So we have 21 minus 2, which is 19, all over 6. So the answer here becomes 3 and 1 over 6. Okay? Yeah. Now, this is basically the procedure on if you are actually adding or subtracting fractions. You just find the LCM, the lowest common multiple. Let's look at this one. You have 1 minus 9 over 10. So what do we do in this case? What we do here is to write, we can actually say this is a whole number, then we are subtracting a fraction. So we can change the whole number here into a fraction by simply saying, okay, this is, yeah, one student would do this, would just say this is 10 over 10, so that he has the same denominator as this one. So 10 over 10 becomes 1, okay, minus 9 over 10. So you have, if you have the same denominator, there is no need, you know, it's 10. The LCM is 10 still. So 10 into 10 goes once. 1 times 10 is 10. Minus 10 into this goes once. 1 times 9 is 9. Then you are going to have 10 minus 9, which is 1 over 10. Easy. Now let's look at this one. Let's look at this one. Okay. Let's look at this one. 7 5 over 12 times 6. Now what do we have here? This is a mixed number multiplied by a whole number, so let's change this into an improper fraction. So we are going to have 12 times 7, which is equal to 84, then plus 5. We get 89, okay? 89 over 12 times 6, okay? So what we do here is just to say, okay, 6 into 6 goes once, 6 into 12, it goes 2 times. So we have 89 divided by 2, okay? So 89 divided by 2, 2 goes once in here. In 8, it goes 4 times. In this, it goes 4 times and leaves 1. In 1 it doesn't go. Okay, we can put a point here and then say put a 0 here. 2 into 10 goes 5 times. So the answer is 44 and a half, or 44.5. I'm saying and a half because of this mixed fraction. So I decided to make my answer a mixed number. But you could still leave it as a decimal if you don't mind, which would be 44.5, right? Yeah. Now, so at least we have looked at a few good examples here. Let's look at um, 5. Work out 7 plus 0.25. If you have this, it's obviously it's wise for you to work it this way, to say 7 to say 7.00 plus 0.25. You align the vertical points to keep the place value. Okay, units, tenths, hundredths. You add the hundredths together, you get 5. The tenths together, you get 2. The units together, you get 7. So the answer would be 7.25. Okay, that is the easiest approach. Now, let's say we had this one. We had 7 minus, okay, 7 minus 0.25. Even if it's minus, if you are subtracting a decimal number from a whole number, write the whole number as a decimal, then minus 0.25. 0 minus 5, no way. So we're going to take 1 from here and put it here. Take 1 again and leave 9 here and put it here. 10 minus 5 is 5. 9 minus 2 is 7. So 0.6 minus 0 is 6. So the answer would be 6.25. Now, now we will look at this one. This one. 0.1 times 1000. When you multiply a decimal number by the powers of 10, you just shift or move the decimal. You just move the decimal. How many steps? The number of 0 steps. There are 3 zeros here, so you are going to move this decimal to the right 3 times. So it will be 1, 2, 3. The decimal point will be somewhere. So in this position, you put a 0, and this also is 0. So it means that your answer is going to be 100. Okay? Let's have this one. The same number but dividing this time. 0.1 divided by 1000. You are dividing by a multiple of 10, the power of 10. So what do? You're going to shift the decimal point. Now, because we are dividing, we are going to shift it to the left. How many times? 1, 2, 3 times. You just count the zeros. So it will be 1, 2, 3. So you put a 0, you put a 0. So you have 0.0001. You can say 0.001. Okay? So that is how you can move. When you multiply, you move the point to the right. When you divide, you move the point to the left. Okay? Yeah. Now with this, now we have tried to do these things here, and then it looks like these are the basics. This is actually the math that you need to know to understand. Should be at your fingertips. Okay. All right. Now let's continue. um, part 3, we are going to look at the conversions, how we convert kilometers, centimeters, millimeters. So how many meters? We want to find meters. How many meters are in 2.5 kilometers? How many meters are in 2.5 kilometers? Okay. Now here you want to find how many meters are in 2.5 kilometers. These are just conversions. They are very common. Now what do? You have to first of all say 1 kilometer. I know that 1 kilometer is equal to 1000 meters. That's where you start. 1 kilometer is equal to 1000 meters. Now you want to find the number of meters in 2.5 kilometers. So you will say 2.5 kilometers is equal to how many meters? So make sure that kilometers are on one side, meters on the other side. Okay? So the conversion here, the standard conversion here will guide you. You need to remember this. Now what we do here is just to cross multiply. Okay? We just have to cross multiply. This times this equals to this times this. But now the kilometer will cancel the kilometer. So 1 times x is x, which is equal to 2.5 times 1000 meters. 2.5 times 1000 meters. So we are multiplying by 1000. We are going to move the decimal point 1, 2, 3 times. So we are going to put a 0 here, 0 here. So that is 2500 meters. Okay? Yeah. As simple as that. As simple as that. Now, um, uh, here we want to find the number of meters in 52.5 centimeters. We want to find the number of meters in 52.5 centimeters. So we will start with the conversion, standard conversion between meters and centimeters. So we will say 100 centimeters equals to 1 meter. 100 centimeters equals to 1 meter. Therefore, 52.5 centimeters equals to how many meters? So we are going to cross multiply, but centimeter cancels centimeter. So 100 times x is going to be 100x, which is equal to this times this, which is equal to 52.5 times 1 meter, which is 52.5 meters. Now we are going to divide by 100 so that we solve for x. Okay? We divide by 100 on this side to balance. So when you divide by 100, you are going to move the decimal point 2 steps to the left. It will come here. 1, 2. So you are going to have your answer as 0.525 meters. Okay? Therefore, there are 0.525 meters in 52.5 centimeters. All right? That's easy. That's easy. Let's look at this one. How many meters are in 273 millimeters? How many meters are in 273 millimeters? So what we know is that 1000 millimeters is equal to 1 meter. 1000 millimeters equals to 1 meter. So 273 millimeters is equal to how many meters? So we cross multiply. Millimeter cancels millimeter. This time is this. This time is this is going to be 1000. X equals to this time is this, which is 273 meters. So we divide by 1000 to cancel, so that we have x equals to, we divide by 1000 here to balance. So the point is going to move 1, 2, 3 steps. It will be here. So we are going to have 0.273 meters. Yeah, this is as easy as this. So the conversions will always appear, especially in paper 1. Now you need to be careful. You need to be very careful. Even in paper 2 you will meet conversions. Okay? Yeah, now we have covered this much, and we will continue and get to part 4, whereby we are going to be looking at plotting. Okay, plotting points on the grid or on the graph. Plotting points on the graph. Now um, let's say we have a question that says plot the points A, -2, +2, B, -2, -1, C, +3, -1, D, +3, -4. Okay, you are asked to plot these points. So when you plot the points, what do? You need to understand that there will be the x and the y axis. Let's just say we have the y axis, the x axis, and then we will say we have the divisions. This would be -1, -2, -3, 1, 2, 3. Obviously we have 0 here. -1, -2, -3, -4. 1, 2, 3, 4. So if it were on a grid, thus our axis would appear smarter, but it doesn't matter. We will see the concept. Now, -2, comma 2, -2, comma +2, this value is looked for on the x-axis and this one on the y-axis, and where they intersect we have that point. -2, comma 2, then it's somewhere here. -2, comma 2 will be somewhere here. That would be point A. -2 on the x-axis, +2 on the y-axis. Okay, now -2, -1, -2 on the x, -1 on the y. It's somewhere here. This point will be somewhere here as point B. 3, +3, -1, +3, -1. Here, this point would be here as point C. All right, I'm sorry. Now, +3, -4, +3, -4. This point would be somewhere here as point D. Okay, yeah. Now, you have plotted those points A, B, C, D. Okay? Draw the lines AB, BC, and CD. AB is this line. AB is this line. Here you join this two. It's line AB. The line BC would be this one. BC would be this one. BC, okay? I believe it should have passed here over -1 right here, okay? Let's remember it passes here, okay? If we were on a scale drawing, all right? Now, CD is this one. CD is this one, okay? This is CD. Now, we have joined AB, BC, and CD, okay? Now, uh, um, the figure has rotational symmetry of order 2 at a point. Write down the coordinates of this point. This figure has order of rotational symmetry. Order 2 of rotational symmetry. Rotational symmetry actually, we did talk about this. Rotational symmetry, order of rotational symmetry actually. Order of rotational symmetry. Order of rotational symmetry. So the order of rotational symmetry means you are going to rotate this shape at a point such that as it's rotated in one direction, say clockwise, there is a time when it fits in itself again. It fits, the vertices just overlap. The vertices just overlap. Once all the vertices overlap, we say order 1. We turn it again in the same direction. When they overlap again, we say order 2. Okay? So it means that at a certain point when this shape is rotated, it overlaps twice before getting to its original position. That is why we say it has order 2. Now, that point should be here. This one. When we rotate it here, it will go and this point will get here. Okay? That would be order 1. Then it rotates again and the point goes back to its original position. That is order 2. Okay? So that means the coordinate would be 0, -1. Yeah. The coordinate, because they wanted us to find the coordinates of the point where it's rotated. So this is the point, which is 0, -1. Okay? Yes. The next question, they say, write the equation. Write the equation of um, uh, write the equations of AB. Equations now. Equations of AB. AB is this line. What is the equation of this line? This line is parallel to the y-axis and it cuts x-axis perpendicularly at 90 degrees at perpendicularly at -2. So the equation of this line is x equals to -2. It cuts x-axis at -2 perpendicularly. So it's x equals to -2. Let's find the equation of BC. What is the equation of BC? BC cuts y-axis at -1 perpendicularly. So the equation is y equals to -1. Okay? CD. What is the equation of the line CD? CD would, or if extended, it would cut x-axis at positive 3 perpendicularly. So it's x equals to positive 3. Those are the equations. Okay? Now, shade the region Y, shade the region Y, shade the region Y is less than -1. Where is Y -1? Y is -1, it's here. So Y is less than -1, it's below here. It's this region here. Below BC. This is the region Y is less than negative. The Y values here in this region are less than -1. Remember that if -1 is here, 0 is greater than -1, 1 is greater than -1, but -2 is less than -1. So anything below -1 here, it's less than -1. So this is it. But now, if we shade the region Y is less than -1, we must draw a dotted line here for less than, because they are not saying less or equal, they are saying less than. So if there is no or equal, then it must be a dotted line. If there is or equal, then it's a bold line. Okay? Okay? Yes. Now, that is what you need to understand. That is what basically need to understand. Okay. Now, let's continue. Let's go to part 5, whereby we are going to solve equations. Solving equations. Now, we have the equation 2x over 3 equals to 6. How do we solve this equation? If you are to solve the equation, it means you are going to find the value of x. Now, there are certain things that you need to do. Okay? Okay? What you do is to eliminate this fraction here, so that 3 cancels 3. Multiply by 3 on this side to balance. So you are going to have 2x is equal to 18. You want x here, so eliminate the 2 here by division, so that this cancels this. Multiply by 2 to balance. So your x will be equal to 18 over 2, which is 9. Okay? Yeah. Yeah. Now, let's look at this one. 5x minus 3 equals to 17. Solve. You want to find x. Let's remove this term first. If it's minus 3, let's say plus 3, so that it becomes 0 plus 3. Okay? So we say plus 3 on this side to balance. Plus 3 on the left hand side to make this 0, so that we are left with 5x equals to. On this side, plus 3 to balance. What do you do on the left hand side? You must do on the right. So 17 plus 3 is 20. Okay? So when we are here, 5x is the same as 5 times x. We want to eliminate the 5 so that we are left with x. So we will divide so that we eliminate the multiplication here. We divide to balance. So x is 4. You have solved the equation. Okay? Now, this one, 4x plus 9 equals to 21. Solve. What do you do? How do you do this one? How do you solve this one? Okay? There is plus 9 here. When they say solve, you must find x. So remove this plus 9 by minus 9. Minus 9 to balance. Plus 9 minus 9 is 0. So on the left hand side, we have 4x equals to this minus 9. This minus 9 is 12. Then 4x equals to 12. We want to eliminate 4 so that we have x alone. Let's divide by 4 so that 4 cancels 4. We divide by 4 this side to balance. So x will be equal to 12 over 4, which is 3. So you have solved the equation. All right? Yeah, that is how we solve equations. Part 6. Part 6. Now simplifying. Okay? How do we simplify? Let's say you have this. 6a plus 3b minus 2a plus b. Okay? How do we simplify this one? When you simplify, you collect like terms. So you have a's and b's here. 6a's minus 2a's. 3b's plus b. Okay? So let's put the a's together. We are going to have 6a minus 2a. You take this with the sign just before it. Then you take this one, which is plus 3b, and then you take this. You group them plus b. So you have a's and b's. Now simplify. 6 minus 2 will be 4. 4 what? A. 3 plus 1, there is 1 here. 3 plus 1 is 4. 4 what? B. So this is simplified. Okay? This is simplified. This is simplified. Now, let's look at this one. 5x squared plus 2xy minus x squared plus 3y minus xy. All right? What do you do here? X squareds are this, and then xy's are this. So this one, the y's, we have only one term. Let's put the x squareds together. Let's put the x squareds together. So we are going to have 5x squared minus x squared plus 2xy minus xy plus 3y. Be careful. We take a term with the sign before it. We take each term with the sign before it. Okay? Now, what happens here is that 5 minus 1, there is 1 here. 5 minus 1 is 4. 4 what? 4x squared. Here, 2 minus 1 is 1. 1 what? 1xy. You can say it's xy or 1xy. It doesn't matter. Then we have plus 3y. So we have simplified. We have put x squares together, xy's together, and then the y's together. So that's how we simplify. Okay? Yeah. Now, let's look at this one. What about this one? Here, you have the x's and then the constants. So let's put the x's together. 5x minus 4x plus 3 plus 8. Simplifying, 5 minus 4 is 1. 1 what? X. 3 plus 5 is 8. So this is simplified. This is simplified like that. All right. So I think this is enough for this presentation.